Welcome to lesson 3.3 on forms of a line. You have seen the first form of a line called slope-intercept form back in ninth grade in Algebra 1. It is probably the only form you've seen so far, and it is called slope-intercept because you need the slope, which was m, and the y-intercept, which was b. That's what those two letters stood for in case you forgot. Well, today you are going to learn another form of an equation of a line, and it's called the point slope. Now, this form looks a little more complicated, but it is actually much easier to use because you don't need the y-intercept, which is, if you think about it, the y-intercept is a very specific point on a line, right? It is a single point. You have to use that point. But for point slope, you just need any point on the line. So you could use the y-intercept if you wanted to, or you could use this point up here, or this one up here, or this one down here. You could use any point on the line. As long as it's on your line, it has to be on your line, obviously, but you could use any point. There's an infinite number of points you could use to plug in for this formula. You still need the slope, so that's why you'll still see an m, but you don't see a b anymore because you don't need the y-intercept. You need a point, and that is denoted by the x1, y1. Notice there is still just a plain old x and a y like there is over in the slope-intercept form, but then you'll notice an x1 and a y1. So you're going to use any old point denoted by x1, y1. Those will be numbers, and you're going to plug them in into those spots. You're going to plug in what the slope is. It will also be a number, and then you can leave your answer in this form. If you don't like your answer in that form, you can distribute your slope into the parentheses and get y alone so that it looks like this one, but that's not necessary. Okay, so before we do some examples with those two types of equations of lines, we're going to review really quickly what you know about parallel lines and perpendicular lines. So parallel lines, if you recall, the special thing about parallel lines is that their slopes are equal or the same. So if you had two lines, both of their m's would be exactly the same. So you would have two m's of 2, for example. Now don't forget, slope is just m. It's not mx. A lot of kids think that there's an x with the slope, like it's 2x. No, the slope is just a number. It's telling you how far are you going up and how far are you going over. It does not have an x with it. So perpendicular lines is the one that's a little more difficult than parallel. Parallel is pretty easy. They're the same. Perpendicular, their slopes are what we call negative reciprocals. And I think in the past, some of you called them opposite reciprocals, or maybe you didn't even know these words and you just said, oh, I just flip it. So what you're going to do for negative reciprocals, if I give you one slope, let's say it was 3, to find the perpendicular, and by the way, this is the symbol for perpendicular in case you forgot from geometry. To find the slope of the line that's perpendicular to it, you flip the fraction. That's what it means to be a reciprocal. You flip the fraction upside down. Now remember, any number that's not written as a fraction is really 3 over 1, or some number over 1. So that when this flips upside down, it's going to be 1 over 3. And then the negative doesn't mean it will always be negative. It means switch the sign, because if it were a negative already, it would turn into a positive because it would be a negative negative. So you just have to know that the slopes are going to have opposite signs. So my original was positive, so my perpendicular one has to be negative. And that's it. So make sure you know perpendicular lines, negative reciprocal slopes. So here we go. Here's our first example. And our only example, but there are multiple parts. So the graph given below, or to the side, is of a linear function. Write the equation of this line in this form, y equals mx plus b. So this is the one you've been doing. So you need to identify the y-intercept. The y-intercept is right here at 1. So I'm going to write down, I know that b is 1. The other thing you need to know is the slope, which is m. You just got to count rise over run between any 2 points. So that's up to right 1. So the slope is 2 over 1. We usually just write 2 though. So the equation of that line is y equals 2x plus 1. What must the slope be of a line that's perpendicular to this one? So the slope of this line is 2. So my perpendicular line would be that fraction flipped upside down. So it's going to be, instead of 2 over 1, it'll be 1 over 2. And you got to change the sign. So this was a positive slope, so it's going to, the perpendicular one will be negative. Part C says draw a line that's perpendicular to this one. So remember, perpendicular, they look like a T, right? They're going to make a 90-degree angle. And it has to pass through the point 1, 3. So I'm going to plot the point 1, 1, 2. So the point 1, 3 is already on that line. So you can visualize it's going to look something like this. We don't want to just like draw any old random line. You want to make sure it actually is perpendicular. So I know, according to B, that the slope that I'm going to be using is -1/2. So if I start at that point that they told me I had to start at, I have to include 1, 3. I'm going to go down 1, right 2, down 1, right 2, or up 1, left 2. Remember, if you're a negative sloping line, you should be going down to the right. So if you connect those lines, it should look like that line is perpendicular. It should look like there's a right angle between that line and the given line. Now, this is the new part. This is probably the most important part. It says, write the equation of the line you just drew in point-slope form. So to use point-slope form, you still need the slope. So I'm going to identify my M. The slope of my new line, my red line, is -1/2. Now, what I don't need is the y-intercept, which is cool because if you look at this y-intercept, it's not pretty. It is going to be some decimal. So we would have to do some algebra to figure that out. So instead of doing that, though, we can use the point slope form, which means I get to pick any point for x1 and y1 as long as it's on my line. Well, to make it easy, I'm just going to pick 1, 3, which they told me I had to have on my line. And now I'm going to take all of these numbers and plug them in. Here is the equation again. It's always y minus y1 equals m times x minus x1. And you're just going to plug those numbers in. So in for y1 goes 3. So it's y minus 3. Remember, it's always a minus. So if your number that you're plugging in for y1 is negative, it's actually going to turn to a plus because it'll be a minus minus. So be careful. The slope was -1/2, and then x stays x, and then in for x1 goes 1. So it's x minus 1. Same thing. It's always a minus. So it's x minus whatever x1 is. So if x1 were negative, then it would be a minus minus, which would actually turn into a positive. And that's your answer. Much easier than doing a bunch of algebra to find the y-intercept, which you could do, but it's going to be a little more work. All right, part E, last part says, does the line that you drew contain the point 30, -15? Well, you could sit here and try to plot, keep going all the way over to 30 and see if that y coordinate is -15. But instead, you could use your equation that you just wrote, plug these in for x and y, and see if the left side equals the right side. So I'm going to take my equation, y minus 3 equals -1/2 times x minus 1, because that's the equation of my red line. And I'm going to plug these numbers in for x and y. So in for y goes -15, and in for x goes 30. And I'm going to see if the left side now equals the right side. So -15 minus 3 is -18. 30 minus 1 is 29. And a negative half of 29 is -14.5. Clearly, left side does not equal the right side, so no, that point is not on that line. And that is it for lesson 3.3. So now on to lesson 3.4. 3.4 deals with more lines, but it's word problems, and we're modeling what happens in a word problem with a line. So example 1 says Dia was driving away from New York City at a constant speed of 58 miles per hour. So when we're dealing with lines and you hear constant, constant anything, constant rate, constant whatever, that is your slope. He started 45 miles away, which that's your y-intercept. Where you start is your y-intercept. That's when your x is 0. So it says write a linear function that gives Dia's distance. So instead of using x and y, they want you to use d and h. So his distance, to calculate his distance, you would take how fast he was going per hour. You would multiply it by the number of hours. So that's 58 times the number of hours, plus he didn't start at 0. He actually started 45 miles away. So he didn't start like at New York City. He started 45 miles away from New York City. So you have to add on the 45 miles. So that's part A. Part B now wants you to use your equation and figure out how many hours it would take him to drive 270 miles. So we know our distance. Our distance is 270, and we're trying to find how many hours that would be. So I'm going to solve for h. So you're going to subtract the 45 over to the other side. That is 225. And then you would divide the h by 58. And it says round to the nearest tenth, and that should give you a hint that your answer is not going to be a nice whole number. It is 3.9 rounded to the nearest tenth. So 3.9 hours. After that long, he will be 270 miles away from New York City. Okay, so example 2 says, this one you're going to need a calculator for, okay? I'm going to try my best to draw my graph on here. I'm not the best at writing on this yet, so bear with me. But it says a factory produces widgets, which are just some object, and the cost in dollars to produce those widgets is given by this formula. So C stands for cost. You take the cost, the formula you will do is 0.18, so 18 cents times every widget plus $20.64. Each widget then sells for 26 cents. So revenue is like how much money you gain. To find the revenue, you're doing 0.26, so 26 cents times every widget. Use your graphing calculator to sketch and label each of these linear functions, and be careful, they tell you what interval to use on the w-axis, which is the x-axis. So in your window, you're going to have to set the interval to show up to 500. Usually it only goes, the default setting is from 0 to 10, so you're going to have to change that to 0 to 500. With that being said, I'm not going to go up by ones because I'd have to do 500 little lines. I'm going to go up by 100s. So I'm going to do 100, 200, 300, 400, and then up to 500. And don't forget to label 0. You don't need to see the negatives because that one makes, well, hopefully that one doesn't make sense that you'd be in the negative for dollars. Hopefully you're gaining profit. So let's set our window to not show any negatives. So it should be 0 to 500, and then we'll do 0 to, I don't know, I'll go up to 100. I know it's definitely the lowest point is going to be 20 when I graph this line because that's my y-intercept. So if I go up by tens, I'm only going to label, though, every other. So I'm going to label every other by multiples of 20, but really I'm going up by tens just so it doesn't look as messy. 60, 80, and 100. Now I'm going to go to my table to get some points. To do a line, you only need to plot 2 points and then take your ruler and connect them. So if I look at my table for the C function, okay, I'm going to use the y-intercept, so I'm going to plot as best I can 0, 20.64. And then another point I'm going to use is 200, 56.64. So if I try my best to plot, 20.64 is kind of hard because it's not an exact point on my graph. 200, and then this is about 50, so halfway between 50 and 60. plot those 2 points, and then take your ruler and just connect them. Make sure you use an arrow though, because it does go on forever, hopefully. And then I'm going to, for the R function, I'm going to use the y-intercept, which is at 0, 0. And then I'm going to use the same x-coordinate. 200 is at 52. So 0, 0 is really easy to plot. 200 should be a little below this one, so maybe that wasn't a great one to pick, because they're going to be pretty close. You might want to pick a different one, but so then you're going to connect those two, and they should cross. Hopefully, well, my spacing is a little off, so that's why it's not going to cross where it looks like it crosses on your calculator, but that's okay. So now that's part A. Part B says use the intersect. So you should notice that they do cross, and you're going to use the intersect function on your calculator. If you don't know how to do that, make sure you see me so I can help you. But where they cross at the point 258, 67.08. So what that means, if you recall what X and Y stand for, X is your widgets, Y is your dollars. So if you sell 258 widgets, you will make $67.08. So that's what that means at that point. Okay, the revenue will equal the cost. So basically you'll be kind of at 0. You will have made enough money to pay off what it costs to start up the business and make enough widgets. So you're kind of at 0. After that point, everything that's made is profit. So you can put that in your bank account and spend it, right, on fun stuff. So if profit is defined as you take the revenue and you minus the cost. So profit equals the revenue minus the cost. Write an equation in terms of W. So I don't want to see R and C. I want to see W in there. Well, R was the function, or sorry, yeah, R was the function 0.26W. And I'm going to subtract off the cost. Now I'm going to put it in parentheses because you got to make sure you subtract everything in the cost. So the cost function was 0.18W plus 20.64. If you forget the parentheses, you will remember to subtract the W, but you may forget that he also has to be subtracted, the 20.64. So you're going to have to change the sign. So this turns into 0.26W minus 0.18W minus 20.64. Now you can combine your W's for a final answer of 0.08W minus 20.64. And that's your final answer for your profit equation. And that's it for lesson 3.4.